Well, good afternoon, David. It's nice to be with you today. My name is Casey O'Neill. I am in business development for Roma Manufacturing, and I focus on the industrial furnace market. And I have with me here today David Pridmore. David, why don't you go ahead and introduce yourself?
Good morning. My name is David Pridmore, and I am a sales application engineer for Roma Manufacturing.
So today, David and I are together to specifically talk about water-cooled transformers. You have the old adage, you can't mix water and electricity, and I talk to a lot of users of furnaces and OEMs where they're very hesitant to use water-cooled transformers because in their minds, water and electricity don't mix. So David, tell me a little bit about water-cooled transformers.
In general, there are three types of transformers: air-cooled, water-cooled, and oil-type. Roma Manufacturing has been in the business of water-cooled transformers since the 1980s and has produced over 1.1 million transformers. Some of the benefits of water-cooled transformers include smaller size, a greater efficiency, and a reduced cost compared to air-cooled transformers.
Wow, over 1 million transformers. That is a lot of transformers, all having water running through them. Why use water in a transformer?
The simple answer is that water is just so much better at cooling electronic equipment. Water is 23.5 times more efficient at transferring heat than air. Further, given a specific volume of water flow over a component, water has a heat carrying capacity of nearly 3,500 times that of air.
That's an incredible improvement in efficiency over air-cooled transformers. How does water cooling work?
In a transformer, there are primary and secondary coils, as shown here. The secondary coil is fewer turns and is the high amperage circuit in the system. As you know, electrical current is what generates heat by Joule's law and is directly proportional to the current through the circuit. We have designed our water-cooled transformers with channeled busbar in the secondary high current component of the transformer. We plumb water cooling directly to go through this high current secondary. So it's quite an ingenious way of how we directly cool the hottest part of the transformer. That's how we cool our transformers.
That is really ingenious, I agree. What are some of the other advantages of water-cooled transformers over air-cooled transformers?
Because of how a component needs to be cooled, air-cooled devices are not environmentally sealed and can be exposed to harsh byproducts of your application. This requires more maintenance and earlier failures because of inadequate cooling. With our water-cooled transformers, we encoat and encapsulate our entire transformer in epoxy, thus protecting it from the environment.
Well, I can tell you, in talking to a lot of people, maintenance is always a huge consideration when looking at purchasing equipment. Let's get to the nitty-gritty though, and this is what we hear from everybody out in the field. Isn't water dangerous around electrical equipment? Can you go ahead and respond to that?
Casey, that's a great question, one we get all the time. The simple answer is that water is actually a great insulator with how we use it in our application. Current will always seek the path of least resistance in a circuit. When a transformer is properly connected and grounded, water acts as an insulator. The dielectric strength of tap water, or the typical water that you plumb through your system, is quite high. Furthermore, most of our customers are already using water in other parts of their process, so plumbing another water fold is not that big of a deal.
Okay, great. Well, I think that certainly should help ease some of the minds of people out there using transformers. Now, you touched on this a little earlier, but I'd like you to go into a little bit more detail on what makes a water-cooled transformer more efficient.
When you compare a water-cooled transformer to an air-cooled transformer, the physical size footprint is much smaller, as you can see here in the picture. I could take a 123 kVA transformer and place it right here on the table in front of me. Additionally, because of how the transformer is smaller, there's less surface area to cool, and we require less magnetics or core to power the transformer. This all adds up to smaller impedances and greater efficiency.
Well, to me it sounds like there are a lot of upsides to using a water-cooled transformer in a furnace application. Are there any downsides?
As with any technology, there are trade-offs. With water-cooled electronics, lack of water flow can damage the component. So lack of water flow can come from a clog in the system or variations in the water supply. In light of this, most of our customers will place flow meters in parts of their process. This helps to quickly identify any lack of water flow. Additionally, Roman routinely places thermal switches and thermocouples in the transformer to quickly identify any overheating of the transformer. Another component of water cooling is how it relates to green energy. You can imagine how much water can flow through your system while in operation. Customers who are concerned about this will typically use chillers to recycle their water supply.
Well, that's all great information, David. From what I hear, water-cooled transformers reduce maintenance, they improve efficiency, and their footprint is significantly smaller. All really great benefits, especially when you're in a vacuum furnace application. And I know that, like you said, Roman does do a lot of work to make sure that the transformers are getting cooled, and they put thermocouples in, and also are very intelligent on how to set up a system so that alerts are made to the furnace user when there is some overheating occurring. I appreciate everyone's time today. Now I'd like to open up the floor. If anyone has any questions, we'd love to answer them. I'm talking to you. You!